Okay, let's take a few of those, and I'm gonna give everybody in here one to do, okay? So that we can do it quicker. So we're gonna start, let's make a little chart on our table. On our paper.
Yeah.
Okay, we're doing number of sides. Okay. And I want you to find the perimeter, so we need n, which n is n times the sine of 180 over n, okay, times 2 pi, right? Well, let's not do it. I don't know what I'm saying. Okay. So then it's, the perimeter is 2 times n r equals the perimeter of the polygon. Okay, so we're going to start with 10 sides. Then we're going to go up to 20, 40, 80, 120, 240, and 360. Okay, so this is the number of sides. So Aaron, we're going to start with you. You're taking this one. Luke, you're taking this one. Micah, you're taking 20. Harrison, you're taking 80. Jake, you're taking 120. Paxton, you're taking 240. And Lene, you're taking 360. Okay, so what I want you to find in here is n. I want you to find n in here, and then show me what the perimeter equals over here. R, so we're just gonna leave R as R in this case, okay? The first one, the N shouldn't be too hard, the big N, capital N.
Wait, why am I getting 0 whenever I do sine 180?
Do you want like long numbers? Do you want the full number or?
Whenever I do sine
Yes,
180.
the full number. Write it out as far as you can for N. Now remember, this is number of sides.
What, I don't even know.
180.
I'm 360, right?
Yes,
Sine of 180, right?
it's 180 divided by your number of
Yeah.
sides. 180 would be 0.
Yeah.
Yes.
Okay. So 5.
Oh, you got yours. Oh, yeah.
That times 40. Okay. I think I'm doing this right.
Oh, I remember that one.
Okay, you borrow your calculator.
Wait, what's the radius?
It's star.
Oh,
Yeah, just put the number toward times R. Okay, let me do something. Where's my button?
Whoa.
Oh, this is your,
I already got pi.
this is the one that doesn't have sign.
So the numbers are
And
in
that times
Oh, they're on my phone.
R. What's our? It's R.
capital N equals this formula, and then
So I got the small n is the number.
I got 6.2.
small n is the number of sides.
6.26.
Okay, what is going on? Let me get this back.
What number do you
on my
want?
calculator. There we go.
I think I'm doing this right. For the first one, I got 3.128.
3.1.
Whenever it has 40
Why is
sides,
it not?
big N would equal 3.138.
I got 3.141 for 360.
And multiply by 2.
But we're
Yeah, you should be super close.
And then you
So.
put that in section.
I got 3.1407852.
And
That's
then, so you'll get that answer, and then put that,
6.276 is what I got for the
Let's see
perimeter.
what pi equals here. Pi equals 3.1415559. Okay, mine's 3.14155, and this is 3.14159.
Okay, you're super close.
Like super close.
What are you on? Oh,
I'm at
Paxton's 240.
3.138,
Okay.
so I'm kind of close, but I only have 40 sides.
0.02.
put a R next to it,
I'm
and then equal.
And then my perimeter is 6.276 R.
on 1,000.
Mine is 6.283105559 times R.
Okay.
So,
We're just supposed to do it in terms of R, right?
Yep.
Okay.
I got 6.28.
yeah. Okay.
Around.
Wait, how many sides do you have?
Oh, you.
Okay. Yeah, you're gonna.
I'm 1,000 off on my back. I got
I'm 100. Basically.
Well,
Okay, so let's start with Aaron. What did you get for your N?
I got 3.090169944.
I didn't get the last four, but that's okay.
Do you need the full big number?
Yep.
Oh.
Are you gonna do that again? Okay, Micah, give me 40.
3.138.
Stop.
wasn't round.
Okay.
Oh, yeah, that was me rounding.
3.1407852.
I'm sorry, was it 1-4?
07852.
Okay, Jake?
I got 3.141233797.
Okay, and Paxton?
3.141552779.
Looks like you.
And Lene?
3.141527779.
Okay, how come you guys got the same thing?
Paxton, you were supposed to do 240.
Did you do 360 or
You did
240,
I did
Paxton?
360. Oh, I was supposed to do
P.
240?
240.
Oh.
P.
Lock in.
240.
I thought those were random letters. I was like,
I'm trying to
They don't mean
What does
anything.
P equal?
Okay, going
okay, let
back
me do
to Luke, what did you get?
I was like, what? And that they're off centered, so P is at 120 right now.
What's radius? How did you get radius?
That's enough. Okay.
Radius is
It's
Should
done.
just
be. Okay.
Yeah.
So we're gonna get Paxton's in there. I am going to write in, I did 1,000. Okay, 1,000 sides. Okay, so let's see what we got when we did 1,000 sides. This is what I got. And I don't know why I included that because I don't really need to. 415. And then pi is 3.14159265336.
I want to go outside though and look at the hole. It's crazy. Is it deep?
Okay,
Okay, I got mine.
yes.
3.141502937, and then, oh no, we're not doing the other ones yet.
Yeah, don't worry about that yet. It will actually turn out to be 2 times pi times r, which is really the perimeter, okay? So what I'm trying to show you is this would be 2 times 3.09 times r. This would be 2 times 3.1286 times r. This would be 2 times 3138 times r. And down here we get to 2 times okay. So, what do you notice about these numbers as the sides get bigger?
It's closer.
Gets closer to
Pi.
what?
Pi.
Pi, okay?
Pi
Why do
is-
you think that would be true? As the number of sides gets bigger, why is it getting closer to pi? Yes.
Because a circle has like infinite number of sides.
A circle has an infinite number of sides, okay? We can't say, so we could get closer and closer and closer and closer by increasing the sides up to 2 billion, 3 billion, 4 billion, 5 billion,
But then
okay?
you'd be like, the difference would be like a billion decimals out.
Yes, it would be way
Yeah,
out there.
that's true.
I only did 1,000.
It's so bad.
Right.
I only did 1,000, and look how close I'm getting. I'm clear out to the, let's see that, tens, hundreds, thousands. I'm out to the 100,000s and being close to what our pi is, okay? So if you wanted to increase this and try this, you could see that you will get actually closer and closer to pi, which is one way they came up with what pi is. Okay, that's how they've been working on it to get it to more and more and more digits. But we have to keep increasing the number bigger and bigger and bigger and bigger and bigger to get it out as far as we can. And we've never got it to stop. No matter how many sides we put in, it will never end. It's an irrational number. Okay. The other way, though, that's not how they started with pi. This came later. The other way they really came up with pi was when they were trying to determine the circumference related to the diameter of a circle. So when they were making wheels, they could figure out how big their wheel was going to be based on the on the diameter, and then they kept coming up with this ratio that was closer and closer and closer. The more they got accurate in measuring that distance, they came out with this 3.14. So 2 ways to show how they came up with pi. This was the old way. Through that, it wasn't exactly the same thing, okay? But then once they discovered this, they went into calculating it more and more according to this way, and that's how they've come up with a more accurate pi. Because I'll tell you, we cannot be that accurate in our measurements, okay, to get that. But we can be pretty accurate now because we have special computers that measure and stuff like that, so you can be pretty accurate. You can get a diameter almost identical. The circumference may turn out to be a little bit harder to find exactly, but you can get very, very close with the exactness of our technology today. And again, that's why they keep taking it out farther and farther and farther in pi, and they find that it never ever does end, so they call it an irrational number. And so instead of writing 3.1415926 da 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 out, they give it the number or the letter pi. So that's why it's giving a letter to represent it, because it doesn't ever end and it doesn't ever start repeating. We can't write it as a fraction or anything because it doesn't do that. Okay? So when you were taught in younger ages to use 3.14 as pi, that's actually misleading, because then most people think, oh, pi is just 3.14. It's not. It's got a whole lot of numbers past it, and they never repeat and they never start, they never end. And so that's where I don't like it when people say, let's use 3.14, because then people think, oh, that's what it is. No, it's really not. It's a number that's irrational, okay? And I just tell them it's a number that's got a lot of things behind it. And for this, I would use a calculator. Now, back in the day, they used 3.14, they used 3.1416 or 15, depending on how you wanted to call that, okay? So they would use, depending on how accurate they wanted to be, they would use different lengths of what they knew pi was, okay? But that's still an approximation, it's not an exact. And the bigger your numbers get, the more you're gonna be off, because if you approximate at 3.14, you're going to be way off if you use that for really large numbers, because the larger our numbers get, the more our errors become. Okay, so that's basically what chapter 14.4 is all about. It's just showing you that you can take this number of sides, and what it becomes is basically what we find is that this is really 2 pi r, which is actually what we get for circumference. Okay, so using that, this comes closer and closer to pi. This is pi, and notice that's what we have. So I shouldn't have had you multiply by 2 there. I should have had you just write it out as 2 pi. I was kind of trying to show you that, look, it's 2 pi r is what we get in every case. Okay, and so I was just showing you that's how they've come up with this formula for this, for the perimeter of a circle. Because we're just doing it as more and more and more and more and more and more and more sides. We can't get to infinitely many. That's just impossible for us. We could go really close, but we can't go to infinitely many because it just keeps going on. You can always add one more side, go farther. Okay, so that's really what we're looking at. So let's do a few problems, just quickly. So turn in your book. We're going to do it together. We're not going to go up to the boards. I'm going to ask different people. So,
I forgot my book.
okay, well, why don't you go look at his? Okay, so on page 593, everybody turn to page 593.
Oops, there.